All right, today we need to go back and fill in our 11.4 ISN. We talked about regular polygons last time, and today we're going to talk about them again, and we're going to do 11.5, or at least get it started. So in your ISN, you have the parts of a regular polygon. I don't know what happened there. I forgot to erase all of that. What I was going to highlight there was that the radius, of course, goes from the center to a vertex, just like you see the circle on the outside. This is called a radius of the regular polygon. The apothem is the segment that goes from the center to the side perpendicular to that side. It does bisect that side as well. But what you need to know is that the formula for the area of a regular polygon is half of the apothem times the perimeter. Now, the perimeter is the blue part, all the way around the outside. So since a regular polygon has all congruent sides, if you know one of the sides, you just multiply by the number of sides to get the perimeter. Now, as far as the formula goes, I tend to do the apothem times the perimeter and then divide by 2. So that's sort of how I'm going to do them. Find the area of each regular polygon, round to the nearest tenth. So I see that it has a side of 10.9 and it has an apothem of 7.5. So we know the apothem is 7.5 meters. We need to find the perimeter of the figure, which is 5-sided. So we do 5 times 10.9, and that's 54.5 meters all the way around. So the area, we're just going to pop those values into the formula. You take your apothem, 7.5, times the perimeter, 54.5, and divide by 2. So grab a calculator and start typing. Okay, so our answer, we're going to go ahead and round to the nearest tenth, 204.4. And that is in square meters. Okay, example 2. The apothem is told to be 12. This is 12. So 12 inches for your apothem. Your perimeter, there are 8 sides to that figure, so the perimeter is 8 times 10, or 80 inches. And the area, we're just going to do 12 times 80 divided by 2. So it doesn't matter when you divide by 2. So if I divide 12 by 2, I can do that in my head by doing 6 times 80. That'd be 480 square inches. Okay. Now we're going to look at some composite figures. A composite is a figure that can be separated into regions that are basic figures. To find the area of a composite figure, separate the figure into basic figures of which we can find the area. The sum or difference of the areas of the basic figures is the area of the figure. Find the area of each figure and round to the nearest tenth if necessary. For the first one, I have a rectangle and a what? What's the other part? Good, half a circle. So you want to think, I got to do half of an area of a circle. So I'm going to do the rectangular part first, which is going to be just 15 times 34. So when I do 15 times 34, don't probably do that in your head. We get 510 for the rectangular part. Okay. So I got 510 plus, okay, now I'm going to think about what shape I have. This is only half a circle, and the area of a circle's formula is pi r squared, but we're going to cut it in half because it's only half a circle. What would the radius of that circle be? What is the radius of this? How'd you get that, Aaron? Oh, it was Sammy. 15 divided by 2. 7.5, correct. I couldn't tell who spoke because I knew what direction it was coming from. So we're going to do pi times 7.5 squared divided by 2. Pi times 7.5 squared, but we need only half of it. We got 88.4 for that portion. So we got 510 plus 88.4. Our total is 598.4 square feet. Okay, what two shapes do we see on the next figure? All right, so let's do the easy part. The rectangle, because you've been doing those since 6th grade probably. Base times height or length times width is going to be 10 times 5. So that's an area of 50 for the rectangle. Now I need to talk about the triangle part. So I say, well, what's the base of that triangle? Yes, that would be 5. But I don't know the height. How do you know the height? Okay, so you said subtract 10 from the 18 to get 8. All right, area of a triangle. Base times height divided by 2. We've got a base of 5, a height of 8, and we're going to cut that in half. So 40 divided by 2 is 20. So I'm going to take 50 plus 20. My total area for this figure, yes, Michael, 70 square units. Thanks for saying the square units, because we didn't have a label on there. We'll just say whatever the units are, squared. Okay, we have 2 more composites. Oh, there's a hole in these. So we need to think about what shapes we're going to be looking at here. We've got, oh, I think I'll get the solid, a triangle area, but there's a big hole in it of a circle. So we're going to have to do what? Triangle, you got to take that out. We only want the area of the blue part. So we'll find the area of the whole thing. We'll find the area of the circle, and we'll need to take the whole area of the triangle and subtract the circle. Okay, so let's just think if we did the area of the triangle, it's base and height. So base times height, don't forget to divide by 2 because it's a triangle. I'm going to put in the numbers, and then I'll be subtracting from that pi r squared. Okay, so those are the formulas. I got the formula for the triangle, the formula for the circle, and now I'm going to plug in the values. Thank you, DeAndre. Base 10, height 7, minus pi times, what's the radius of that circle is, yeah, it is the 2.8 times 2.8, oops, well, I don't know what happened to my writing there, 2.8 squared. We can type that all at once if you want. 10 times 7 divided by 2 was what Kate said a minute ago was 35, right? So then I'm going to do pi times 2.8 squared. That'll be the circle part. I've got 35 minus 24.6. Which is, I know somebody's done it already. It's 10.4, right? Thank you. Oh, square units. All right, so look, any strategies do you want to give me to do the next one? Why? Okay. Now I think about somebody doing this. What am I probably thinking about? Skateboard? Half pipe. Yeah, exactly. That's what I was thinking of. Reminded me of a half pipe. What's the shape of a pipe? So you said to do base times height, which is a good first step. We have a square minus a, how much of a circle though? Half. So we need to take out half of a circle from that square. So that's a pictorial of what it is. The base and height, 8 and 8. Area of the rectangle would be 8 times 8, or the square. We're going to have to take away the area of the circle, which is only going to be pi r squared divided by 2. So what is the radius? Sure would. Yep, it's 4. The way you can tell is because the diameter, of course, will go across this way. And if you cut that 8 in half, you get your radius. So we're going to be doing 8 times 8 minus pi times 4 squared divided by 2. Okay, so I got 25.1 for the circle part. We're going to go to the 10th. And then I would subtract, oh, wait a minute. Oh, 8 times 8. I forgot to write what 8 times 8 is. How about I just write that that's 64, since we know how to multiply those numbers. 64 minus 25.1. 38, did you say? 38.9? And that's going to be in square inches, because there is a label on that one. Okay? We are going to go on to the 10.5 ISN today. Why? It's the next page. Well, get ready. You can do it. Now, I apologize. These really don't look like squares, do they? They look more like rectangles. But if they're squares, the ratio of their sides would be 3 to 10. Can't reduce 3 to 10, so that's the answer. Now, if you found the perimeter of the first figure would be 3 plus 3 plus 3 plus 3, which would be 4 times 3, or 12. The perimeter of the second one would be 4 times 10, so it would be 40. Oops. We want to do the ratio of the perimeters, so that would be 12 to 40. Well, what's that reduced to? If you divide 12 and 40 by 4 each, you get 3 to 10. Ratio of the perimeters is the same as the ratio of the sides. What about the areas? Well, the area of this figure would be 3 times 3, or 9. And the area of this one would be 10 times 10, which would be 100. The ratio of the areas is 9 to 100. Do you see a relationship? How could you go from 3 to 10 to 9 to 100? What would you have to do to a 3 and a 10 to get a 9 and a 100? Amato said square them. Yes. Area is in square units. Perimeter is the length. So, and sides are a length. The lengths are always in the same ratio. The areas are taking the length ratio and squaring it. So if you have a rectangle, similar rectangles, if they are similar, meaning they're in proportion, the ratio of the sides for these would be A to 2A. Well, how does that reduce? If you cancel out the A's, you would replace them with 1. A divided by A is 1, and you would get 1/2. The perimeters would also be in the same ratio of 1 to 2. But the areas would be, see, A times A would be A squared. 2A times 2A would be 4A squared. And if you took A squared to 4A squared, you would get 1, 2, 4. Now, did you have to do all that work to get it? No. You can just take the ratio of the sides and square it. So what we're finding out is that there is a pattern. The ratio of the sides is equal to A to B. The ratio of the areas, is there say areas in your box, or I thought maybe I'm missing something there, would be A squared to B squared. So whatever your side ratio is, you square the numbers to get the ratio of the areas. Now we're going to have to do some application of that. So the ratio of the sides is going to be A to B. The ratio of the sides squared is the ratio of the areas. Oh, and I'm sorry. I probably shouldn't write A to B here. Let's change that to, sorry, perimeters. The ratio of the sides equals the ratio of the perimeters. They are the same. The ratio of the sides squared gives you the ratio of the areas. Similar triangles apply, all figures apply that are similar. So find the scale factor. It's telling us triangle JKL is similar to triangle PQR. It says that the area of JKL is 40. That's an area for the first figure. Find the area of PQR. So I want to find the area of this figure. I know this area is 40. If I'm going to be working with areas, I need to know the ratio of the areas. Okay, so what I can start with, all I've been given here are a pair of sides. The ratio of the sides is 10 to 12, which would reduce to 5 to 6. If the ratio of the scale factor and ratio of the sides are one and the same thing, then the area ratio would be 5 squared to 6 squared, which is 25 to 36. Now I will use my ratio of my areas to find the area of the missing figure. So we're going to write a proportion. 25 over 36 equals, okay, now look at your figures. I have areas 40 for the first one. Is it larger or smaller than the second figure? The first one's smaller than the second. So I'm going to put the 40 where the smaller number in correspondence with the smaller number. So it's going to go on top. And the A we're going to find goes on the bottom. That is our proportion. We're going to cross multiply and divide. And I know most of you just go ahead and type it all at once. But if you went 36, cross products are equal by proportion properties. 36 times 40 is 1,440. And then you would divide that by 25. Show it. Okay, so what is the actual area of that larger figure? You said 57.6. Thank you, Nathan. That would be in square inches. Okay, another type of problem. Anybody still need this? I can pause a minute. Okay, scale factors and finding missing measures in similar figures. You can also use the areas of similar figures to find the scale factor between them, or find a missing side or measure. It says a parallelogram ABCD is similar to the parallelogram FGJH. Find the value of x. First, find the ratio of the areas. So we compare 64 to 49. 64 to 49 would be the ratio of the areas. Now, how do we go backwards now to get the ratio of the sides? Guys, we want to go from here to the side ratio. When we had the sides, we squared them to get the areas. So we're going backwards. Say it louder. Nathan. Square root. Oh, I don't know why I went back that far, but here we go. To find the scale factor or ratio of the sides, we're going to unsquare 64 and 49. So that's 8 to 7. All right, now that we know the ratio of the sides is 8 to 7, we can find x. So a scale factor of the ratio of the sides is 8 to 7, or that's the same as the scale factor. My pen's stuck. Okay. Equals, and now we got to decide which way to put it. Is it going to be 10 over x or x over 10? Okay, bigger over smaller. Yes. Larger figures, the first one, its ratio, the similarity ratio is 8 to 7. All right, cross products are equal, so we got 8 times x equals 70. Excuse me. 70 divided by 8 is about 8 point what? 75? Is it? Oh, does it stop there? Great. So we'll just write the whole thing. And that would be in meters. Okay. Anybody still need this? I can go to the next one. All right. For the pair of similar figures at the right, find the area of the shaded figure. It is this baby little triangle over there. And I'm going to find its area. I know the area of the larger. I'm trying to find the area of the smaller. I see a side length on the first one of 16 and on the second one of 3. So the ratio of the sides, or scale factor, or the similarity ratio, is 16 to 3. If the ratio of the sides is 16 to 3, the ratio of the areas is 16 squared to 3 squared. Oh, my 6 looks weird. 16 squared is 256. 3 squared is 9. That's what I need to use, area ratio, because I want to find an area. So now I write a proportion. 256 over 9 equals 38, top or bottom. 256 is bigger than 9, so the bigger figure's area would go on the top. 38 to A. I just used an A because it's just a reminder that I'm finding a area. All right, let's go ahead and just cross multiply and divide. We get an area of 9 times 38 divided by 256. This is going to be little. Oh my gosh, 1.3. That's it. I don't want to write that whole number. We'll round to the 10th. Didn't say what to do, but I'm doing that. 1.3 square inches. Oh, that was square meters. Okay. More practice. These will be the two types of problems you have to do using this concept. You'll have to go forwards and backwards. So if we're going to find an area, we'll compare the sides are in a ratio of 8 to 5. So the areas would be in a ratio of 8 squared to 5 squared. I want to find an area. So I'm going to write 8 squared is 64, 5 squared is 25. That equals, first figure's area is given to be 32, and it's the bigger figure, so I'm putting it on top. As 32 is to A. Cross multiply and divide to find your area. Okay, 25 times 32 divided by 64. I think it's a lot smaller than what you said. Oh, got it. 800 divided by 64, we get 12 and a half. 12.5 square centimeters. So the other type of problem, if you're given the areas, we can go find the area ratio. And we're going to want to reduce this. 4,590 divided by 510. So I want to reduce that. So I take the calculator and go 4,590 divided by 510. Oh, 9. How am I going to write that as a ratio? 9 to, we got to have, it's not 0, it's 9 to, okay, this reduced to 9. How do you write 9 as a fraction? Nine to 1. All right, that's what I was trying to get at. 9 to 1. We can't have nothing in the, that one spot. Did I? Oh, I don't know. I can't recall now exactly how I said it. Maybe I said something goofy that made you think wrong. So I'll try to clarify. I need to write 9 as a fraction. So it would be 9 over 1. 9 or 9 to 1. Okay, we're going to use the area ratio now. We want to go backwards though. We want to go back to the ratio of the sides because we're trying to find a side. So we have to unsquare this. Okay, so ratio of the sides is going to be the square root of 9 to the square root of 1. The square root of 9 is 3. The square root of 1 is 1. And now we can write our proportion. So we got 3 is to 1 as, go up and find the side length compared to x. Yep, 21 is going to go on top, x on the bottom. So we're going to do 1 times 21 divided by 3, or 3x equals 21, so x is 7. Oh, what label? Meters. Leave that one more left. Okay, the ratio of the sides of two similar figures is 2 to 9 or 2 over 9. Excuse me. The ratio of the perimeters would also be 2 over 9 or 2/9. It's the ratio of the areas that changes, which would be 4 to 81. 2 squared to 9 squared. Okay, so I guess maybe I could summarize a little bit more. The sides and perimeters are in a ratio of A to B. Areas are A squared to, let's see if that pen came, A squared to B squared. Got to know that. All right, so now we're going to go to the packet. And let's get right to it. Little technical difficulties here for a second. All right, triangles. Ratio of the sides for this triangle. I don't care which pair of sides you use, just make them that correspond. You can do 4 to 8, or 3 to 6, or 5 to 10. They all reduce to 1 to 2. All of those reduce to the same amount. Yes, it does. So why bother finding their perimeters, right? 1 to 2. The areas will be in a ratio of 1 squared, which is 1, to 2 squared, which is 4. That's all we're doing for that problem. Pardon? Okay, this one's length. This one's length. That's why they have the same ratio of their length. Okay, this one's areas, which would be, that's area is square units. That's why we square it. Square that ratio of those sides. Do not know. I'm sorry. Thank you for catching that. I was just really quick writing down just so it, and I accidentally wrote one wrong. Thank you for saying something. I don't like wrong things on my paper. Does that make sense now? It is 4 to 8 half, 3 to 6 half, 5 to 10 half. All right, squares. Squares, ratio of the sides for this pair is 2 to 9. The perimeters would then also be 2 to 9. The areas would be, 2 squared to 9 squared, 4 to 81. If you have circles, these radii are length. The ratio of the sides would be 3 to 7. The perimeters 3 to 7. Areas 9 to 49. 3 squared to 7 squared. 3 squared is 9. Some kids write 6. Does not mean 3 times 2. It means 3 times 3. And 7 times 7 is 49. If you're doing rhombi, ratio of the sides A to B. Ratio of the perimeters would also be A to B. But the ratio of the areas would be A squared to B squared. So we generalized it down. That's the format for all similar figures. Okay, so the ratio of the sides equals A to B. Oh no, sorry. I wanted to write or the equal to the perimeters. And ratio of the sides squared is the ratio of the areas. And that's A squared to B squared. All right, so sides and perimeters are the same. Area is when you square it. For each pair of similar figures, find the area of the shaded figure. Okay, so we want the big area. So we're going to say, okay, the ratio of the sides is 2 to 6. 2 to 6 can reduce to 1, 2, 3. The ratio of the areas then is 1 squared to 3 squared, which is 1, 2, 9. We're trying to find an area, so we need to use the area ratio. So we write a proportion. 1 over 9 equals 20 over A. And I put the 20 on the top because it was the smaller figure. And I want the area of the larger figure, so it should be in the same position as the larger number. Okay, cross products. 1A equals 180 square inches. Two, same problem, but, ooh, the ratio of the sides is our decimals, 10.5 to 15.5. Okay, so if the ratio of the sides is 10.5 to 15.5, I want to show you how you can convert that without and have no decimals in your ratio, because you shouldn't have decimals in your ratio. So grab your calculator, type in 10.5 divided by 15.5. And then hit math, enter, enter. And I did something wrong. Where's my math, enter button? Somehow I didn't hit the button. Okay, yep, 21 over 31. Does anybody see a way to get that without? Did you see how the calculator just multiplied these by 2, didn't it? Yeah. It just gets rid of the decimals. Gives you a fraction that's not, doesn't have decimals in it. All right, 21 over 31. We're going to take that and do the areas now. The areas ratio or area ratio, I don't like that grammar there, would be 21 squared to 31 squared. So we're going to have some pretty big numbers here to do. 21 squared is 441, I believe. Yep. And 31 squared, it's going to be 600, 900 and something. 961. 441, 961. Okay, we are going to need to put our 200 top or bottom. Okay, smaller figure, yep, top. And then our A on the bottom. Cross products are equals to do 961 times 200. And then divide by 441. Or 35.8. Okay, scale factors and missing, we're just doing a couple more things. Scale factors and missing measurements and similar figures. You, of course, can use areas of similar figures to find the scale factor between them or find a missing measure. So what we need to remember is that if your ratio of your sides is A to B, and it will also be the same for the perimeters. The ratio of the sides squared, A squared to B squared, is equal to the ratio of the areas. Again, if the sides were A and B. corresponding sides get compared. For each pair of similar figures, use the given areas. Now we're going to take the areas. We're going to want to reduce this. So I'm going to 54 divided by 216. Math, enter, enter. I got 1 to 4. If the ratio of the areas is 1 to 4, then sides would be square root of 1 to the square root of 4, which is 1 to 2. You then use that to find the x value. So we're going to use 1 is to 2 as 8 is to x. And that's because we went smaller to larger. Cross products give you x equals 16, and that would be in inches. Same idea on number 4. I'm going to go ahead and stop now for today. Happy Friday. Have a nice weekend. At least it's Friday of 2017. Today is May 5th, Cinco de Mayo.